Looking at 7.6 next, one of the things that can be troublesome for students when they're first learning statistics is trying to figure out what do I do when. And what can help you is knowledge of your notation, knowledge of the constructs and the terminology and the wording under which we work and how those are related together. Okay? So here we read our information, and it tells us that we have something that is approximately normal. So I have a variable, it's approximately normal, right? Mean is 100, standard deviation is 15, right? Here's mu, here's sigma. Always, always, always label it. Make it clear. What is the probability of a randomly chosen individual? Well, if I have an individual, I can think of it as n equals 1, right? And that they have a score of 105 or larger. So I'm looking for the probability that x is greater than 105, right? Which is the same as 1 minus the probability that x is less than 105. Right? And really this is 105 or larger, so technically it should be or equals to. Okay? And I need the z-score. Right? If I work through the z-score, I would get that I have 1 minus the probability that the z-score is less than or equal to 0.33. Right? Standard computation of the z-score. Put that into my calculator or look into the table, and I get 0.3707, meaning that a randomly selected individual, about 37% of them have a score higher than 105. Okay. What if I want the mean and the standard deviation of a sampling distribution where I have 60 people? Well, that would be n is equal to 60. Because I come from a normal population, x bar is approximately normally distributed, right? And it has some mu and some sigma over root n as its standard error or its standard deviation, right? What does mu equal in this case? Mu, we know, is equal to 100, and sigma of x bar, and this is mu of x bar, important that we write the right notation, sigma of x bar is equal to 1.9365 approximately. Alright, that's just 15 divided by the square root of 60. Okay, note that if we're setting up with this, it's always good to talk about the 10% condition, right? And we know that n is less than 0.10 of all adults. Our sample size is less than 10% of our population. All right, so we're looking for the probability that x bar is greater than 105, which, or at least, which is the probability that z is greater than or equal to 2.58. Using my calculator, I get that that's about 0.0049. So if I got a group of 60 people that was randomly selected, it's highly unlikely that their average IQ was above 105. However, if I grabbed a large group of people from a university, then it might be a lot more likely that they have an average IQ above 105 because their mean might be quite a bit greater than 105. If they're at university, they probably have a higher IQ. Okay. What is the probability that the average score is 105 or higher? Well, that was what we just did. Okay. And then finally, would any of the answers be different? Well, A could be different if x was not normal. Right? Because we wouldn't be able to use the normal distribution to figure out the probability, so it's possible that that probability were different. Okay. B is no change. Right? Mean and standard deviation are going to be the same regardless for the sampling distribution of x bar, right? The mean will approximately be the mean of x, and the standard deviation will be the standard deviation divided by the square root of n, right? And C, well, our central limit theorem applies, so therefore no change there either. Okay. The more you practice, the better you get. 7.7, that review exercise, once again, you can find that in the book in Chapter 7 review. It can be very helpful. And you might also consider doing the chapter test to help you out. Okay? The next class, you'll have a quiz over chapter